Today we will be learning about negative exponents. What do we mean by negative exponents? Well, negative exponents are a bit different from normal negative numbers. So let's see how we evaluate negative exponents. So let's say we have a 3 raised to a negative 2 power. What do you think this equals? Well, some of you might say, since 3 squared equals 9, shouldn't 3 to the negative 2 equal negative 9? And that's a good guess, but this would be true if it was just multiplication. For example, if I'm wondering what 3 times negative 2 would be, then since 3 times 2 equals 6, 3 times negative 2 would be negative 6. And this is okay for multiplication. But for powers, this actually doesn't work. And the reason is, powers are not the same as multiplication, first of all. And powers are actually a step above multiplication. So let me show you what I mean here. If you focus on this side here, when you multiply just by a positive 2, you get 6. When you multiply by a negative 2, you get a negative 6. And what is the relationship between 6 and negative 6? Well, these are additive inverses. Additive inverses. Oops, I'm missing a few letters here. Additive inverses, which means if I add them together, I'll get the additive identity. Oops, let me write the identity down here. Additive identity, which is 0. This is the additive identity. And the similar rule can be applied for negative exponents. When I do 3 squared, I get 9. When I get 3 negative to the negative 2 power, I should get a number here that is the inverse of 9. But this time it's going to be a multiplicative inverse. Multiplicative inverse. And the reason it should be a multiplicative inverse is because for multiplication, think of it this way. So here's multiplication, here's addition, and here's exponent. Multiplication is an easier way to do addition. Right? Multiplication is an easier way to do addition. If you're adding a lot of things, you can just simplify it as multiplication. So for example, if you're doing 3 plus 3 plus 3, you can just, or plus 4 3s here, you can just simplify that as 4 times 3. So multiplication is a step above addition. And the same thing is true for exponents and multiplication. When you have lots of multiplication together, you can use exponent to simplify that. So exponents are now a step above multiplication. So when you did multiplication here, you got the additive inverse. You got the inverse of the step that's right below. So for the exponential expression here, you need to get the inverse of multiplication, the inverse of the step that's one below. Okay, so if this part confuses you, then don't worry too much about it for now. Just know that when you are dealing with negative exponents, you have to get the multiplicative inverse. So what is the multiplicative inverse of 9? In other words, what when you multiply times 9, 9 times what gives you the identity, multiplicative identity, which is 1. And for some of you, you might recognize that 9 times 1/9 will give you 1. So the multiplicative inverse is the reciprocal. So when you see a negative power, a negative exponent, think multiplicative inverse or the reciprocal of that number. So let's do a few more problems here. You might be confused right now of all the things that I've said, but it's not as complicated as it sounds, and you'll see it. So for example, if I have a 4 to the negative 2 power, if that was the positive 2, what would that be? 4 to the positive 2 would be 16. But since it's a negative 2, you have to think of the reciprocal or the multiplicative inverse of 16. And what is the multiplicative inverse of 16? The reciprocal of 16 would be 1/16. Right, so the 4 to the negative 2 would be 1/16, not 16. How about 5 to the negative 3? Okay, so what is 5 to the third, first of all? 5 to the third is 125. So 5 to the negative third would be the multiplicative inverse of that, or the reciprocal of that, which is 1/125. How about 7 to the negative 1? 7 to the negative 1. Let's first evaluate the positive version of that, which is 7 to the 1th power, which is just 7. So 7 to the negative 1th power would be the reciprocal of 7, which is going to be 1/7. Okay, so when you have a negative power, think of the reciprocal of the multiplicative inverse. And this, you can do this with fractions as well. Let's say we have 2/3 to the power of negative 2, 2/3 to the negative 2 power. This is asking for the multiplicative inverse, so think of the positive version of this. So the positive version of this would be 2/3 to the positive 2 power, and we've learned how to evaluate fractions raised to a power. That's 2 squared over 3 squared, which is 4/9. So for the negative 2 power, it's just going to be the reciprocal of 4/9, which is 9/4. Okay, so that's how you can evaluate even negative powers of fractions. Let's do one more. Let's have 6/7 negative 1. Okay, so to evaluate this, let's first look at the positive one, which is 6/7 to the positive 1 power, which is just 6/7. So for the negative 1 power, it's just going to be the reciprocal of this, which is 7/6. Okay, so when you see a negative power, first evaluate the positive version of that, and then just find the reciprocal. You can just do that. And then after, with practice, for example, if you have something like this, with practice, you can just automatically do this in your head. You can automatically think, okay, 6 squared is 36, but since there's a negative here, I need to do the reciprocal of 36, so that's going to be 1/36. Or 10 to the negative 3. Okay, so without the negative, that's 10 cubed, which is 1,000. But since there's a negative there, I need to do 1/1000. So once you get familiar with this, you can kind of skip a few steps here. But if you're confused at first, I recommend that you follow the steps like these. So first evaluate the positive version and then find the reciprocal, as I've done them here.